Okay, so in this video, we'll try to understand how and why divide and conquer approach is suitable for solving the maximum sum subarray problem. So, when we talk about maximum sum subarray problem, it is essential to basically solve a problem which is of a very, very smallest size. Like the size of the problem will decide sometimes the complexity related to that problem. So if we want to reduce the bigger problem into smaller problem, the best approach is divide the problem into smallest subproblem. That is divide and conquer. So in case of maximum sum subarray, the smallest problem will be of size 1. That is, the size of the array will be of one element. And to get any bigger array of size n into a smaller array of size 1, a binary division concept is applied. This binary division will generate the array of size 1 from the array of size n in log n base 2 time. That is very important to understand that it will not require n minus 1 cuts. It will only require log n to the base 2 cuts so that the array of size n gets divided into array of size 1. In the next slide, this concept will be more clear. So what you can observe here is, if you see that there is an array, and in this array there are total n elements. The size of n here is 12. Like we have 12 different elements in this array. And if you want to divide this array into smaller subarrays, the formula for division will be low plus high divided by 2. So for example, if this is the array, first element and 12th element, this will be low pointer and this will be high pointer. And we can cut the array from the mid pointer by running a formula recursively, low plus high divided by 2. So it is 1 plus 12 divided by 2, that is equal to 13 by 2, that is equal to 6.5. So first cut will be at the sixth element of the array. And in this way, we can further continue and divide the array into smaller subarrays. So first is 6, then next is 1 plus 6 by 2, then 1 plus 3 by 2, and then 1 plus 2 by 2. So finally, you get an array which is of size 1 here. Now, if we want to find out what is the maximum sum subarray in this particular array of size 1, then it is simply 5. This is simply minus 3. So in this way, in one iteration, we will be able to solve the maximum sum subarray problem for this array of size 1. Now the problem gets slightly complex when the size of the array increases. So in the next level, if you see here, the size of the arrays increase from one element each to two elements when we combine this. So what is the idea when we combine the array, and what is the different types of sums which we get when we combine the array? That we can try to understand in the next slide. So let's go further. So here, if we take this smallest array, then in this array, the sum of the elements present is 5. Now, if you just try to combine this array into a next level sub array of size 2, then there is a possibility of different sums. And those different sums will be basically termed as left sum, right sum, and center sum. So if I say what is the left sum of this array, then I will only consider the left part of this array, which is 5. So if I take what is the left sum of this array, then I will only consider the left part. What is the right sum of this array, then I will consider only the right part. So for this, the left sum is 5, right sum is minus 3. And there is another possibility that when we combine these two elements, this will generate another sum. So 5 plus minus 3, that is equal to 2. Now we have three different sum. One is left sum, 5. One is right sum, that is minus 3. And one is center sum, that is 2. And out of this 3, we will take the maximum, which is maximum of L, R, and C, which is equal to 5. So if I want to declare what is the maximum sum of this subarray, then it will be 5. And when I am applying this idea, the advantage is I'm not solving this complex full problem. I'm just solving the component of this full problem. So if I move further, then there is another possibility of getting the array of size 2 here combined with array of size 1 here. And this will generate array of size 3. Now we want to understand what is the possible maximum sum in this three elements. So for this, again, what we can do is we can take the lower reference, that is what was the left sum, what was the right sum, and using this left and right sum, we'll try to find out what is the center sum. So if I take what is the left component of this array, this is 5 and minus 3. And what is the, so it's very simple. If I want to find the left sum, then I have, if this is my array 5 and minus 3, and which is representing my left component of the array, I will simply pick the maximum element of it. Okay. If I don't have both the elements of same value. So here one is 5 and one is minus 3. So if I further divide this into two parts, I will get 5 and minus 3. And what is maximum out of 5 and minus 3? It is 5. Similarly, here maximum is 9. Now we want to conclude that whether 5 should be picked, whether 9 should be picked, or whether this center sum should be picked. Now if I want to find out of these three what is maximum, I should first find what is center sum. So to find what is center sum, I will simply apply a logic that I will start from the middle element, which is minus 3, and I'll move till the left element, and I'll keep on summing, and I'll get the maximum sum. So for example, if the middle element is minus 3, my center sum is max of minus 3, which is equal to minus 3. Now again I get another version, that is max of minus 3 comma minus 3 plus 5, that is equal to 2. So up to this I have the sum is 2, and using this 2, if I go further here, then I will get center sum equal to max of 2 comma 9 plus 2, that is equal to 11. So I have three values for this array, 5, minus 3, and 9, which is one is 5, one is 9, and one is 11. And out of these three, I'll pick what? 11 here. So in this way, it is possible to calculate the center sum for remaining element. For example, here it is 8 minus 4, minus 8 plus 12, that is 4, and 4 plus 7, that is 11. For example, here it is minus